All right, so we get into volume now. So today is volumes of prisms and cylinders. All right, so your objectives: to find the volumes of right rectangular prisms, to find the volumes of other prisms, and to find the volumes of cylinders. Pretty straightforward. All right, let's start with the volume of a right rectangular prism. Okay, volume, just in case you need a refresher. The volume of a solid is the number of cubic units of space contained by the solid. So if they give you units like inches or whatever, make sure that it's cubed. If they don't, then don't worry about it. All right, let's go to a postulate. The volume of a right rectangular prism is equal to the product of its length, width, and height. You probably know that. Okay, so the volume of a rectangular box is length times width times height, where L is the length, W is the width, and H is the height. So another way to look at it, okay, which is theorem 115, the volume of a right rectangular prism is equal to the product of the height and the area of the base, since area is length times width. Okay, so or just base times height, whatever, where B is the area of the base and H is the height. All right, so let's take a look at an example. Really, really easy. Find the volume of a rectangular prism with a base of 20, a length of 5, and a height of 15. So what do? Length times width times height, which is 5 times 20 times 15, which is 1,500. See? Simple. We'll get a little harder. Let's go on to volume of a cylinder. So theorem 117 states that the volume of a cylinder is equal to the product of the height and the area of the base. Okay, so base times height, and remember the base of a cylinder is a circle, so just pi r squared times the height. Okay, so B is the area of the base, H is the height, and R is the radius of the base. Let's take an example of this. Now, kind of like a triangular prism, a cylinder, if it's laying, it doesn't matter if it's laying on its side or straight up. It's always going to be the parallel congruent parts that are the bases. All right, now notice this is only half of a cylinder. Okay, so we need to find the volume of this. So we have the diameter here of 12 and a height of 25. So volume of a cylinder is pi r squared times the height. So we would do pi times 6 squared times 25, which is 900. But since we only have half a cylinder, we're going to take half of that 900 pi to give us 450 pi. All right, so if you see half a cylinder, just cut it in half. Please don't just give me the volume of a cylinder. Use your brains. Cut it in half. Okay, so that was example 2. Example 3, we have a cylindrical glass with a height of 6 inches and a radius of 5 inches, and it's filled with water. The water is then poured into a rectangular dish with the dimensions of 4 by 5 by 6 inches. Will the water overflow into the dish? Okay, so we want to justify the reasoning using approximate values. So in other words, we're going to use 3.14 for pi. So let's start with the volume of how much water do we have? So we need to find the volume of the cylindrical glass. So we do the volume of a cylinder, which is pi r squared times h. So we'll do pi times 5, because that's the radius, squared, times the height, which is 6. So we're going to use 3.14 for pi. 5 squared is 25, and 25 times 6 is 150. So 150 times 3.14 is 471. So that's how much water we have, 471 basically cubic inches. So now we have the volume of a rectangular box, and we need to see if that's, now if it's going to overflow, that means the rectangular box will have less volume than the glass. So the volume of the rectangular box is length times width times height, or 4 times 5 times 6, which is 120 cubic inches. So as you can see, the water will overflow the dish because there is more water in the glass than the dish can hold. All this water, now I didn't plan this, but look, all this water is the water that overflowed. Oh no, get a paper towel. Oh no. Sad face. Anyway, sorry, just me being goofy, because why? Why am I being goofy? Because we only have 2 more videos. I only have 2 more videos with which to torment you, make you groan, whatever. Anyway, glad we got it done. We're nearing the end of the year. You guys have been an absolute pleasure. So have a good one and hang tough for these last few weeks. We can make it through, and your grades will be phenomenal.